Okay, let's do more, let's do more. You know how much we love to do examples so we can get this stuff solidified in your own noggin. Here's another one. Y is equal to 6x cubed plus 3x plus 1 to the 10th. All right, outside, inside. What's my outside function? Good, that exponent, right? That's an identifying characteristic. When I'm looking outside, inside, right? Up here, we can see that our trig can be our outside function. What is the outside? What is that? That's why we call it outside and inside functions here. Here, my exponent is my outside. That's legit. All right, so let's do this thing. Take the derivative of the outside, keeping those guts. Bring the 10 in front, keep the guts. And 1 less will give me 9. Then multiply by the derivative of the inside. So I just have another polynomial here. So I've got 18x squared plus 3. Now remember at the very beginning and we did all that amazing factoring? Oh, ladies and gentlemen, this is when we get to use our skills. So simplify this. Do you see anything in common here? Yeah, 3. We can factor out a 3. So do your thing. Here, if I factor out a 3, I'm going to bring that 3 up here in front. So y prime is now equal to 30 because I factor out this 3 times what's already multiplied with this 10, 6x cubed plus 3x plus 1 to the 9th, times, when I factor out that 3, I get 6x squared plus 1. Right? You could put that in the back. You could put that up front. It's all multiplied. That's why we could put that 3 and that 10 together, because it's multiplied. Right? Okay. Cool. For the rest of this session, we are just going to do more examples. When you feel like we've done enough, we'll probably do 1 or 2 more. And then you can practice, because the chain rule's a biggie, but it's a goodie. Here's example 2b. Let's try this one on. Finding derivatives, of course. Y is equal to the square root here of 5x squared plus 1. Now tell me things that you see. Yes, I've got a radical. Good. So if I have this radical, as soon as you see that radical, what do? Change it to an exponent. And that radical is also my outside function, right? Pardon me, I can't take a derivative of just a radical, so I have to change it to an exponent so we can actually do work on this thing. So 5x squared plus 1 to the 1/2 power. Yep. Now do your thing, baby. Do your thing now. So I've got 1/2, bring that in front, and I've got 5x squared plus 1. When you subtract 1 from this, right, because it's the exponent, it gives me a negative 1/2 power. Oh, my head did it faster than my pen did it. 1/2 minus 2 over 2 is that negative 1/2 power. Look at what happened here. We kept those guts. You bet we did. Now, multiply by the derivative of the inside, which will give me a 10x. These are all multiplied together. I can't go messing with the inside of this because it's underneath that radical, right? You can't mess with the inside of this, but this is multiplied times this. What's 1/2 times 10? Yes, it is, all day long, right? 2 goes into 10 5 times. It gives you that 5x. Yeah, so just bring the coefficient in front. So y prime is equal to a 5x times 5x squared plus 1 to the negative 1/2 power. And that's our final answer. All right. If you're feeling really saucy and you want to go ahead and make that a positive exponent, you can. I don't think it's really necessary, but that's up to you. It's a negative, so you know it's in the denominator. So that is an option because those are equivalent, right? Okay. Oh, this is so cool. Okay, let's do another one. Example 2c. I want to take the derivative of y equals 5t squared over 3t squared plus 2 cubed. Oh, do you see how exciting this is getting? Outside and inside functions. Outside and inside functions, right? What's my outside? It is that cubed. Keep the guts. 3 times 5t squared over 3t squared plus 2 squared. Now, what happens when I go to take the derivative of this inside function? What do we have to do? That's where we do the quotient rule. As soon as you learn one way in order to take a derivative, that's fair game. Take the derivative of the inside. Okay, now look at that part. Oh, the two things are divided? Hey, no sweat. Let's go ahead and do the quotient rule because we're amazing and we know how. Let me go back to blue here. Derivative of the top is 10t times the bottom, 3t squared plus 2, minus the top, 5t squared, times the derivative of the bottom, which is 6t, all over the bottom squared. All right? Now clean it up. So we have, let's scoot this up a little bit. We get to do some algebra now as well. Oops, I forgot to close that off. That's from these. Now clean that up. What do we have? Y prime is equal to 3 times 5t squared over 3t squared plus 2 squared. And I get a 30t cubed plus a 20t. Ooh, check it out. Minus 30t cubed. Ooh, that's nice. All over 3t squared plus 2 squared. What do you see just happened? Now, that doesn't always happen that way, but it sure is nice when it does. Yeah, so let's do this. I'm going to scoot it up. Now, we are multiplying two fractions together, so kick out those algebra skills. Let's rock the socks off of this algebra. We're not going to have some sloppy answer. When you have a rational expression that is to an exponent, this exponent goes to both the top and the bottom, right? So I really have 3 times a 25t to the 4th over 3t squared plus 2 squared times this 20t over 3t squared plus 2 squared. Now we can combine all that. We've got 3 times 25, which is 75. 75 times 20. Don't get worked up about that and do not use your calculator. Think about this for just a second. 75 times 20. You know this 0 drops out. What is 75 times 2? Yes, it is 150. That, ladies and gentlemen, I expect you to be able to do that kind of a calculation. All right, you don't need a calculator for that. All right, so y prime here is going to give me 1,500 t to the 5th. Good, good, good. You see that? T to the 4th and a t gives me t to the 5th. Good job. And 3t squared plus 2 to the 4th. Yep. And that is our final answer. Let me squeeze this in. See that? Algebra. Algebra. We're going to get to try our skills on. You got this. I know you do. Algebra is amazing. And we're going to rock the socks off of it. Cool.